What's up, math scholars? It's a sunny Thursday outside, and we are about to learn 3.3 day 2. Who's excited to be a scholar today? Yeah, that's the most smiles I've ever seen in this class. All right, we're going to start with a review. We are reviewing function notation. What we have up here is read m of x equals x plus 7, and then p of x equals 2x plus 1. That's how you would read that. So you should have learned this in Algebra 1, so think back to your fun memories with Mrs. Hart, Mr. Butch, Mrs. McDonald, or Mr. Brown. I missed a bunch of teachers, sorry. Lippman, Putney, Billig, naming all the geometry teachers I can think of. Clevidence. All right, so let's do the first one together, and then I'll call up some scholars to make guest appearances on my video. Who's excited? So we're going to take this -5, and we're going to go to equation m and put that -5 in place of x. So it's going to go right there. So -5 plus 7 equals 2, and 2 is my answer. Okay, so when you put a -5 in for x, you get a 2 as your answer. Easy enough? Who wants to grab the marker? You will get a ticket for this, and you'll be a guest speaker on my video. No.
Okay. So you plug in 4 in for x in the p problem, and then you get 4 times 2. And then you add it. And you get 9.
Alright. So you plug in -5 for x, which is 2 times -5 plus 1, which is -10 plus 1, which is -9.
Alright, so you take -1 and put it in place of x for the m. -1 plus 7 equals 6.
I forgot I was recording. All right, our next slide, we're still using the same exact m and p functions, but now we're doing 2-step problems. The way I would read this to you is m of p of 2. And it's a 2-step problem. You're going to start with the innermost parentheses. You always start on the inside set of parentheses and work your way outwards. You're going to start by finding p of 2. So you take a 2 over the p function, and you put it in for x. And that would give you your answer to the first step. So my answer to my first step is 5. The answer, the p of 2, is 5. But now I still have this m here. And what that means is I'm going to find m of 5. So I'll put the 5 right about here, and I'll end up doing 5 plus 7 and getting 12. Okay? We're going to play board buddies in the second one because no one was brave enough to come be on the video. All right, so our group started with putting the -3 in equation m. That's right about here. That gives them a 4 for their intermediate answer. Then they find p of 4, so they put a 4 in equation p. Do 2 times 4 plus 1, get 9. Good job. Any questions from the class? Moving along. All right, so what you just did was a composition of functions. You used 2 or more functions at a single time. And what we're going to be doing is composition of functions today. Sometimes we'll be putting numbers in to both the functions, which is what we just did. But sometimes we'll be using variables. Look at this equation that we're going to be doing. M of n of x? That's weird. I've never seen anything like that. So jot down the equations and I'll tell you how we're going to do this one. Okay, so this is technically called function within a function. You're going to start on the inside, which is here, and you're going to take the whole entire function, n of x, put it in equation m. So I do this with circles. So I will circle my n of x, and I'll picture in my head picking that up traveling over to equation m and sticking it right about here. Sometimes this will need us to distribute or even FOIL. Sometimes we'll just have to simplify, but that's how you do it. You pick up equation n, function n, and you put it inside function m in place of x. Can you visualize that in your mind, how that works? Pick it up, put it here, and now we simplify. So it's just negative 42 x squared plus 8. And of course, on all these today, we'll be practicing writing out the domain. Now this domain is easy. We're just squaring x, so any number in the world can be squared. Negative infinity to infinity is our domain. So really, I was telling my earlier classes, the only thing that's going to restrict your domain is division or radicals. Because you can't divide by 0, and you can't square root or fourth root a negative. But other than that, it's probably going to just be negative infinity to infinity for all of your functions. Alright, I'm going to have board buddies come up and do this one on the left, f of g of 2. And the answer's 13. Okay, so you're going to put a 2 in the equation g, 2 squared equals 4. That's called your intermediate answer. Now you'll put a 4 in the equation f, 2 times 4 plus 5, 13. Very good. All right, let's get 8 more people to do g of f of negative 3. Okay, so they did f of negative 3, end up getting negative 1 there, and then when you square the negative 1, you get 1. Good job. All right, let's do... Actually, I want to do this one. I'm just going to watch the clock. We're running low on time. Been chatting too much or something. So we got g of f of x. So you're going to take the inside guide, the equation f of x, circle it, put it in equation g right about there. That's going to give me 2x plus 5 squared. Now, let's see if you guys are scholars or not. How do you simplify that down?
You box method.
Box method. I mean, yeah. Square root the whole thing. No, we're not solving for x. I think, DJ, as weird as that sounded, box method, what I call the box method is a box method of factoring. I think he might be thinking box method of foiling. Because what we have to actually do here is do a FOIL problem. You have to write the 2x plus 5 twice, and you have to FOIL it out. Is that what you meant by box method?
Yeah.
Okay, and you were right. Definitely don't want to do any square rooting, though. So it's a FOIL party. 4x squared, 10x. Everybody's getting really good at foiling because we do it so much. I think you could probably FOIL in your sleep. So it's 4x squared plus 20x plus 25. Grace, what do you think the domain is? Me and Grace were having domain discussions over there. Yeah, so what values could I put in for x and get a real solution? Actually, any number in the whole world. You can square a negative, right? So it's negative infinity through infinity for the domain. Okay. Hey, I have 2 more concepts to tell you about, and what I was about to say is this is the new concept. It's f of x. You're probably like, what? We've taken function g and put it in function f, and we've taken function f and put it in function g. But how are you going to take function f and put it inside itself? Isn't that weird? Dominic, you have an idea? Right, so what my advice to most people is actually just write f of x a second time. So you can visually see yourself circling f of x, and you can visually see yourself placing it right here. But Dominic got it right. It's x plus 3 plus 3, because that's me putting the x plus 3 in for x. Isn't that cool? So it's x plus 6. So that's the concept of putting a function inside itself. Isn't that so weird? What's the domain of that? Grace, what's the domain of that? Yeah. So the conversation I was having with Grace is if it's just like multiplying or adding or squaring, you can do that with any number, negative infinity to infinity. But when it's a radical or division, that's when you have to be careful, because you can't do division by all numbers, because you can't divide by 0, and you can't do square roots of, or fourth roots or sixth roots of all numbers, because you can't do negatives. All right, then the last concept I need to tell you about All right, last slide of the day. We're not going to do all 4 parts, probably just a part or 2 or 3. I don't know how many. What's that for? Probably 1 or 2. I have that star there because I definitely want to tell you about this concept. The reason I have the star there is when I saw this problem and I wanted to work it out, guess what I did with that x to the negative 1? Flip and make it positive. So I flipped the x to the bottom, made it a positive 1 exponent. And I've got my g of x here. I definitely wanted to do this problem because it has that concept of division in it. And you need to remember, we are not allowed to divide by 0. So no matter what, in our final domains on these problems, when we compose these functions, we don't want 0 to be included in our domain. All right, you just want to do part A? So part A, f of g of x. You're starting on the inside. So you're going to take g of x and put it in function f. So right here, it's going to go right about there. So in part A, f of g of x would be 4 on top, 5x minus 2 on bottom. And that's your answer. There's really no simplifying to be done. Let's talk about what the domain would be. So you are allowed to divide by all numbers in the whole entire world, except you're not allowed to divide by 0. And if I had a 0 in this original function right here, that would have been bad, so we want to exclude 0. But we also want to exclude one more number. Here's what we want to exclude. See this denominator? That 5x minus 2 also can never be 0, in addition to x never being 0. So I'm going to solve this out, and that's going to allow me to discover that x also can't be 2/5. So we have 2 numbers we exclude from our domain, 0 and 2/5. The 0 because of the original f of x, and the 2/5 because of our composition of our function. Okay. Alright, so thanks to everybody at home watching the video. Tonight's homework is a worksheet captured in Polaris. Just look for section 3.3, day 2. Okay, bye.